Hey students, in this video I'm going to go over the attributes of quadratic functions. These attributes you've seen before in our previous unit, so it's not new to you. What's new to you is how these different forms of quadratic equations or quadratic functions can help us find these attributes. So just a quick review, we can find the x-intercept on the x-axis. So it's the 2 points that the graph intersects the x-axis with. And these points are going to be written as x comma 0. Then you have the y-intercept, which is similar to the x-intercept. It's a point where the graph crosses the y-axis. So it's just written opposite 0 comma y. And then the axis of symmetry is a line of symmetry that cuts the graph in half per se, and it actually crosses through the vertex. So using the vertex, we can identify the axis of symmetry, and it's just basically the value that you have for the x on the vertex. That would be your axis of symmetry. Okay, the new things for you are finding these attributes from the different forms of quadratic functions. So like standard form is written in a way where only the last value is an attribute. So it's the y-intercept. And that basically means that you don't have to graph this in the calculator when you could just identify your y-intercept right there. But if you want to find other attributes, then yes, graph it in the calculator if you have it in standard form. If you have a vertex form is called vertex form because you could just find the vertex from the letters H, K. So the values that you have here for H and here for K are your values for your vertex. You do want to remember though that it has to look like this, x minus a value. If it doesn't, then that means you have a negative H. Because if you have an x minus a negative H, then that becomes a positive right here. So it will look like x plus H. So whenever it looks x plus a number, it's actually x minus a negative number. All right, the next part is the y equals ax minus p, x minus q. This is new to most of you. This is an intercept form, which means that just by looking at it, we can find the x-intercepts, or we know them as zeros. And the x-intercepts could be found in the letter p and q in this formula or form. But you also, once again, need to make sure it's x minus p, x minus q. And your x-intercepts end up being whatever those numbers are, p comma 0 and q comma 0. So they're both x-intercepts. They're just written p and q separately. All right, so we're going to have 3 examples right here to point those out. The first one is just analyzing the graph. So we have the x-intercepts right here. So we're going to write them as 1 comma 0 and 3 comma 0. And then in between the x-intercepts, we symmetrically have the axis of symmetry, cutting it in half. So in between 1 and 3, we have 2. And then again, that vertex is created with the axis of symmetry. So the vertex in this case will be 2 comma 1. And the axis of symmetry is at x equals 2. So that's where it's crossing. We have a maximum in this graph because that's the highest that the graph goes, and that's at number 1. So y equals 1. And the neat thing about this is that you can recognize that the vertex is created by the axis of symmetry and the minimum and maximum. So for example, the vertex, if you find that first, you automatically find the axis of symmetry and the maximum or minimum value. Y-intercept is just where it's crossing the y-axis, so that's at 0 for the x, -3 for the y. All right, so when the graph is not able to be easily analyzed like this, for example here, we do need to use a calculator. But before we do that, I want to just point out something. This right here is written in the form of vertex form, which means that just by looking at the equation and ignoring the graph, we could find the h and k value needed for the vertex. It has to follow x minus h though, and it does. So that means your h value is a 2, and then your k is a 1. So notice that without looking at the graph, you could identify the vertex to be 2, 1, and it matches. So that helps. This one though, this one is written in standard form. And because it's written in standard form, we can only identify the attribute of the y-intercept, which is this last value. So the y-intercept here is 0, 4. And if you look at the graph, it is touching at 0, 4. All right, so I'm going to type this in the calculator and use it to find the other attributes. So I'm going to have 1/2 x squared minus 3x plus 4. And this is a graph. So now we're going to do menu, trace, graph trace. And right away it gives us a y-intercept of 0, 4. If we keep going to the right, it says 0 when it reaches the x-intercept. So you need to identify that when the calculator says 0, it is giving you an x-intercept. So at 2, 0, you have an x-intercept. If we keep going, it says minimum at 3, -0.5. And again, that is just identifying that you have a minimum point right here at 3, -0.5. And if you recall from the last example, once you have the vertex, you have these as well. So the axis of symmetry will be the x value, so x equals 3. The maximum or minimum will be the y value, so -0.5. And based on how the graph looks, that is your minimum. Okay, if we keep going, we can find the other x-intercept. So it's titled 0 right here at 4, 0. So I'm going to write 4, 0. And those are the attributes for that second problem. So notice that they do match what we discovered in the calculator. Let's try the next one. The next one is given in intercept form. And when we analyze intercept form, we could find the x-intercepts. So it has to follow the form of x minus p, x minus q. X minus q is there, so 1 is your q. X plus 4 is similar to x minus p, so that means we have x minus a -4, and -4 will be your p. So according to this, just by looking without looking at the graph, we can say that the x-intercepts are -4, 0 and 1, 0, just by looking at those p and q values. Now we look at the graph, that makes sense. It makes sense to say this is -4 and this is 1. So now we can write down -4, 0 and 1, 0 without even graphing this in the calculator. All right, let's go ahead and graph it so we can find the other attributes. I'm going to clear it and type this in. So we're going to type -2, parentheses, x plus 4, close the parentheses, open it, x minus 1. And this graph will be traced, graph, menu, trace, graph trace. And then the y-intercept comes out right away. So 0, 8 is the y-intercept for this. So it should be touching right here. 0, 8. And then we trace it to find the vertex. So it says maximum, and that's negative 1.5, 12.5. 12.5. And if we check or triple check the x-intercepts, it's a 0, negative 4, 0. So that's the one we found here. And then the other one, 1, 0. So that confirms. So like last thing again is if you have the vertex, you have the axis of symmetry and the max and min. So I'm gonna just write these down. The axis of symmetry would be the x value of negative 1.5. This graph touches there at negative 1.5. And then max or min, the maximum to the top, and that would be at 12.5. Okay, so that concludes our mini review on the attributes for quadratic functions. I hope this video helps you.